up to, suppose you have taken a jug to particular level, you can measure its volume, but it takes shape of the container. Suppose if you put the water in jug, it will some take shapes. If you put in the bucket, it will take different shape. If you put some a tube, it will take different shape. So it has volume but not defined shape. Like gas, neither they have any defined volume nor defined shape. Means if you put gas anywhere, they take the shape of that container. Then come to second, particles are tightly packed. Here the particles are very tight, very tight, very tight. But in case of liquid, these are not so much tight, not so much tight. Okay, but here it is compact, tight, rigid. All these things later on we will come to that. These are particles here. And gases, like this is solid, this is liquid, this is gas. So first is defined shape and volume, defined volume but not shape, neither defined volume not defined volume or shape. Then come to particles. Particles are tightly packed, here loosely packed, here far apart from each other. Particles are far apart from each other. Intermolecular force, we have already studied. Intermolecular force which attracts each other. In case of solid, it is very strong because they are very near to each other, so it is very strong. And it is weaker in the liquid, that is weaker than solid. Also we can say that it is weaker than solid. And here in gas it is very weak, intermolecular, because if it had it been strong, then it would have been nearer to each other, but as it is not nearer to each other, so intermolecular force are very weak in gas. Liquid, it is less than solid, and in case of solid it is very strong. Then come to intermolecular space. Intermolecular space, it is very small, negligible. In case of solid, intermolecular space, there is space between the particles. We have already studied intermolecular space is space between the particle. In solid, it is negligible, and it is larger and it is largest. Suppose in case of liquid, you see the gap. This is the space. This is the space. It is very large, and in gas it is largest. So in solid, intermolecular space are negligible, and in case of liquid it is larger, and it is in gas it is largest. Then come to that compressible and rigid. It is incompressible. You cannot compress an iron rod. You cannot compress. It is very rigid and incompressible. And liquid, it flows. That's why it is called fluid. It is one of the important thing. Many exam this question comes, which are fluids. So all the liquids are fluids. So because it flows, that's why it is called fluid. And it flow also and take the shape of the container. So gas always flow and take the shape of the container. Example, iron, sand and stone, water, oil, petrol, milk, alcohol, these are liquid, all the liquid, even blood, air and hydrogen, oxygen, nitrogen, carbon dioxide, these are all gases. So this is the states of matter. There are three states of matter. One is solid, one is liquid, one is gas, and their characteristics. Just remember the five characteristics and differentiate between these characteristics, and you don't need to remember everything. Only key points you have to remember, and you can write in exam whatever required in little bit with explanation. If you remember the key point, you can write something extra also. Okay, just note it down. Let's come to interconversion of states of matter. Suppose we have studied the states of matter, that is solid, liquid and gases. How, suppose one form will change to other form, we can convert solid one state, suppose it is solid, then to other state liquid, then again bringing it to original state, from liquid to gas, then again gas to liquid. This phenomenon, this is the process or phenomenon is called interconversion of states of matter. But these changes, this conversion will occur without chemical change and occurs due to change in temperature and pressure. So these changes, suppose one matter changes from solid to liquid, but chemical composition will not change. Without change in chemical composition, without chemical change, suppose the chemical changes is happening, it means there is no interconversion of states of matter. Means suppose if some liquid is converted into gases, the chemical and gases again, that gas coming to in the form of liquid, then come to the original state. It means chemical changes is not happening, then only you can interconversion of the state of matter occurs due to, how it occurs interconversion, you can, this is occurs due to temperature and pressure. Suppose let's take an example, water. Suppose you take water, first we take ice. Suppose ice is a solid, then come to water is a liquid. Suppose you put some temperature to ice, then water, then from the water is liquid, okay, water is, then ice is solid. If we put temperature to the ice, then it will form the water is a liquid. Again if we put temperature to water, then it will form vapor. What is vapor? Vapor is gas. So if we put pressure, okay, if we put pressure to vapor, then it will again form the water. Then water, if we again water, we put the temperature, like if we make negative degree, temperature is negative or positive, then